Does Earth still have a chance? NASA issues a warning. Asteroid Apophis is heading for Earth. What will happen when this asteroid crashes into the sea off the west coast of the USA is shocking. Neil deGrasse Tyson warns that this terrible day is coming and that we must expect far-reaching consequences. In a matter of hours, the entire west coast of the USA would face devastation. The extent of destruction would be immense, necessitating the evacuation of millions from coastal metropolises like Santa Monica, San Francisco, and Los Angeles. What additional consequences might arise? And is it conceivable for an asteroid of such magnitude to obliterate the entire planet? 13 years from now, the asteroid is set to collide with Earth. Its projected impact site is 500 kilometers west of Santa Monica. Consequently, the trajectory through the Keyhole holds little significance, as it merely adjusts the impact point either deeper into the Pacific Ocean or closer to North America. On April 13, 2029, asteroid Apophis is forecasted to pass within approximately 31,000 kilometers of Earth, a proximity closer than that of most satellites. In 2004, there was a brief period of concern when a 20% likelihood of impact was projected for Apophis. However, the all-clear was subsequently issued, though the threat persists. Renowned astrophysicist Neil deGrasse Tyson elaborated on the Keyhole scenario during a chilling interview. Should Apophis intersect this keyhole, the likelihood of a subsequent impact on Earth increases significantly. Tyson paints a grim picture of the aftermath, envisioning a colossal tsunami that would inundate the entire west coast of the USA in the hours and weeks following the impact. The potential damage caused by the asteroid could tally up to $1 trillion, and our planet could grapple with the repercussions for several years to come. Initial estimations pinpoint the impact site with a high degree of certainty: the Pacific Ocean off the coast of Southern California, a mere 500 kilometers west of the bustling metropolis of Santa Monica. A colossal wave, towering up to 5 stories high, would surge towards the west coast with devastating force. Forecasts indicate that the water would penetrate half a kilometer inland. While this distance may seem insignificant at first glance, the densely populated nature of the west coast underscores the magnitude of the threat. And luxurious resort complexes would all succumb to the sea's relentless advance, along with countless homes in coastal residential neighborhoods. While advance warnings would likely mitigate the number of fatalities, the ensuing damage and cleanup efforts could thrust the USA into a profound crisis. Yet, would the disaster reverberate across the globe? Such a possibility cannot be dismissed, as the potential chain reactions triggered by impacts from larger asteroids remain largely unknown. For now, researchers have given the all-clear for 2029, assuring that Apophis won't pose a threat. Similarly, it was believed that Apophis wouldn't intersect with Earth in 2036. However, one cautious scientist opted to re-evaluate the asteroid and its orbit calculations. What he uncovered is nothing short of startling. The potential impact risk stemming from an asteroid collision has drawn the attention of 2 researchers from the University of Western Ontario in London, Canada, and the University of Waterloo in Canada. Paul Wiegert and Benjamin Hyatt, esteemed experts in asteroid and comet research, harbor concerns regarding the certainty of Apophis's orbit and the genuine threat posed by this celestial projectile. They caution against premature conclusions. According to Wiegert and Hyatt, there exist numerous scenarios capable of diverting a nearby object like Apophis onto a collision trajectory. For instance, they have conducted analyses that explore the repercussions of Apophis colliding with another asteroid in 2029, potentially altering its trajectory. Benjamin emphasizes the potential risk of deviation from Apophis's current trajectory, highlighting how its close proximity to Earth increases the likelihood of impact. He underscores the hypothetical possibility of Apus colliding with another asteroid in space, an event that could trigger a deflection leading to an eventual impact. In their hazard analysis, Hyatt and his research team meticulously scrutinized the orbits of 1.3 million known asteroids within the solar system. This extensive examination revealed the potential for any of these asteroids to collide with Apus, potentially altering the trajectory to our detriment. Employing this data, Hyatt and his colleague conducted the most detailed asteroid computer simulation to date. Fortunately, their calculations provided a sense of relief as they showed no anticipated orbital intersections between Apus and other asteroids. This suggests a high likelihood that Apus will indeed narrowly miss Earth in both 2029 and 2036. Nonetheless, the lingering concern of the Keyhole scenario, echoed by other researchers, remains a point of earnest warning. The concept of the Keyhole suggests that it could redirect Apus on a collision course with Earth. But what do we truly understand about asteroids, their trajectories, and the potential for impact? Despite our advanced calculations and technology, there remains a disconcerting gap in our knowledge regarding asteroids and their potential threat to Earth. While we have not witnessed significant impacts for millennia, a concerning number of smaller asteroids have caught us off guard, appearing in the sky above cities or regions without prior detection. A poignant example occurred in 2013 when an asteroid entered the atmosphere over the Russian city of Chelyabinsk without warning. Measuring only about 20 meters in size, it exploded in the air, unleashing a shockwave that shattered windows in most buildings across the city, home to 1.1 million people. The resulting chaos left many individuals with severe injuries from shattered glass, while others experienced profound shock. This event serves as a stark reminder that the sudden horror of an asteroid impact can occur without any forewarning. The event in 1908, when a 50 to 60 meter asteroid descended over Siberia, likely resembled the chaos witnessed in Chelyabinsk in 2013. This asteroid devastated approximately 2,000 square kilometers of forest, unleashing an explosion that felled millions of trees. This serves as a chilling reminder of the potential devastation a larger asteroid, such as one measuring 370 meters, could inflict. In a recent publication in the Planetary Science Journal, additional researchers caution against dismissing the possibility of Apus posing a threat. They highlight the scenario in which Apus could still collide with Earth, particularly if it traverses a specific keyhole in space. This keyhole represents a critical region where gravitational interactions between the asteroid and Earth could drastically alter Apus's trajectory. If the asteroid were to pass through this keyhole, Earth's gravitational pull might redirect it onto a collision course during its subsequent flyby. The keyhole concept is grounded in meticulous calculations and models that illustrate how a planet's gravity, such as Earth's, can influence the trajectory of nearby objects like asteroids. While the likelihood of Apus traversing this keyhole is exceedingly slim, the potential for its path to undergo alterations remains a sobering reality. NASA has recognized this danger, albeit belatedly. Since the 1990s, a global initiative for planetary defense has been taking shape. In the event of an emergency, readiness is imperative, necessitating unity among nations to safeguard our planet. The impact of an asteroid the size of Apus would indeed be catastrophic enough to devastate the entire west coast of the USA. Yet, the ramifications of such a scenario extend even further. The potential repercussions of an asteroid impact extend far beyond the initial point of contact. Tsunamis could strike island nations in the Pacific, while if the asteroid were to hit land, the devastation would be profound. The force of impact on terrestrial terrain would unleash a vastly different set of effects. The pressure wave alone could obliterate hundreds of square kilometers, ignite fires, and set off a chain reaction of destruction. Moreover, seismic disturbances could provoke volcanic eruptions and earthquakes in sensitive regions, compounding the catastrophe. While Apophis measures a relatively modest 370 meters in diameter, larger celestial bodies are in motion throughout space. Should asteroids several kilometers in diameter collide with Earth, the global consequences would be dire. The asteroid responsible for the extinction of the dinosaurs 66 million years ago, for instance, spanned approximately 15 kilometers in width. Its impact in the sea off the north coast of Mexico triggered a cascade of events including shock waves, fires, seismic tremors, tsunamis, and a catastrophic alteration of the climate. The aftermath of such an impact would be catastrophic on a global scale. Rocks, ash, and toxic fumes ejected into the atmosphere would swiftly spread across the planet. The skies likely darkened for weeks, temperatures plummeted, vegetation underwent drastic changes, and fires raged near the impact site. The sheer force of the asteroid's impact could have ruptured the Earth's crust, leaving both North and South America reeling in shock for months, if not years. The looming threat posed by objects of this magnitude has spurred dedicated asteroid research initiatives led by NASA and other space agencies. These endeavors aim to unravel the mysteries surrounding these celestial bodies and devise strategies to protect our civilization. The OSIRIS probe recently completed a successful mission to collect rock samples from the asteroid Bennu before redirecting its course toward Apophis. Additionally, the DART probe was specifically designed to alter the orbit of a small asteroid, demonstrating the potential to mitigate threats posed by asteroids on a collision course with Earth. This successful experiment offers hope that in the event of an emergency, we may possess the capability to divert an asteroid from its deadly trajectory,